now let's summarize what we've done. We've seen that we have a really rich ecosystem with hardware, in terms of hardware, because we have the evaluation board, discovery board, expansion board, many PCI examples for creating your custom board. A rich software ecosystem with Android, OpenST Linux, Bidroot, OpenWRT, and the Cube LT DSP for programming the Cortex M. A wide set of tools, CubeMX, CubeID, CubeProgrammer, the leak debugger, and also all the stuff that we are presenting in previous slides. You can very easily do DSP porting using the OpenST Linux developer package, because you can use the developer package to create the low-level component, to customize the low-level component of your DSP. And you can use the OpenST Linux distribution to create your custom image, to optimize your custom board, to use external device tree to configure your board. So don't forget our motto. It is a bit old because now we changed it, but it remains valid. So release your creativity using our tools. What I can do now is to explore together with you the repository where this material is contained. So in our hotspot. Okay, inside the folder meta layer, you will find the set of meta layer. It is just a set of folder that will override the folder that are present in the standard DSP. So, for example, if you open the folder receipt kernel Linux, you will find that there is a DD append, so an overlay receipt. If you open the DD append, you will find just 3 simple lines that says, okay, the source URI is the fragment. Okay, as I said, we are using the fragment. And please append to the kernel config fragment this new fragment. We can explore what this fragment do. Entering the file folder, we will find the fragment. And inside the fragment, we can see that we want to redefine some configuration of the kernel. Mainly, on just canceling out, okay? Just a comment is not set, is not set. And this is a simple way to customize the kernel configuration. Let's go back to meta my layer. Another point, U-boot, okay? Inside the receipt DSP U-boot, you find another overlay. In this overlay, I'm just adding 2 patches. We can explore these patches. The first patch, honestly, I don't remember. Okay, I just changed the boot operation. Just said, okay, please start the kernel from here. Very, very simple patch. The second one, okay, it is just the configuration file for the boot. Just simplify the configuration file because I decided to remove the video to compact it. So this is the one thing that I can suggest you to do. Inside the external device tree, you will find the file that we already seen together. So just the list of the device tree that we want to use. And if we explore the device tree, here inside the file folder, device tree, U-boot, no, Linux. We can see in my board the device tree, and on top in the device tree, you can see the string, the label that we've seen on the boot. So my board and the rest of the device tree is taken from the distribution board. I'll not change anything here. This is just the device tree of the discovery kit. Just the other folder was the RAM FST tools. This is very, very easy recipe. This is a recipe that just create the stuff that we need for booting a RAM FST system. So the batch file and the boot argument. and the single operation to create the script. But also this file very very fine, very easy. Files, the such files, we can see that there is the batch file here. That says just to use the Q programmer for using the flash layout RAMFS. There is the TSV file that you see. So partition, RAM-FS, RAM, offset, and kernel, device tree, and the file system. The file system is in a special format you can find on the internet. The CPIO format is the standard format for a RAM file system. And the script. The script is just, no, sorry, the command, the script is here. Okay. Just to say that you want to run the system and you want to use a RAM 0 as a root device. So you want to run the system in the RAM. Okay, the address of the initrd. Okay, I'll just simplified using SH console. But wait, quiet, just to speed up the process. Inside this repository, you also can see the last set of slide that you can use for following this process. So if you want to replicate on your side the operator, you can find here all the same slide that we've just presented to replicate everything on your side.